Hello, Professor. Hello, everyone. We are from Team 3. I'm Hemlata Pulsani, and my team members are Samir and Saryu. Our course project is Learning Analytics System. Today, we are here to showcase our knowledge and present the design of a Learning Analytics System. What is Learning Analytics System? Learning Analytics System is an important tool which is used to gather and analyze the student's data during the learner progress. And this data is used to improve the students' performance and providing the valuable insights to their individual learning habits. So we do have the learning analytics framework for the conceptual and technical types. So conceptual type would include identifying the stakeholders and identifying the needs, means requirements, mapping the data, collecting the data, analyzing the data, and visualizing it. And the technical type would include the design, development, analysis, and assessment. So before starting the development, designing the software engineering models are very crucial. So without the diagrams, we shouldn't be going to the development stage. So to design any model, the scope, objectives, advantages, and challenges need to be addressed. So the scope of the learning analytics system is the data analytics, which is used to improve education at both the institutional and individual levels. It helps education operations more efficient and effective. Coming to the descriptive analytics, so we will be analyzing like what actually has happened to this data. In diagnostic analytics, like what's the reason like this data is behaving this way, like we'll be identifying the reason. And like predictive analytics and prescriptive analytics is like a future insight which will be using to improve the students performance. What measures could be taken from the students educational background and try to provide him the insights and help him improve. So there was an example of California State University. They have implemented some learning analytics system, and it helped the students to gain 25% more compared to the previous term. Objectives of learning analytics systems are like monitoring learners' progress and behavior, predicting learners' performance, generating feedback, provide some recommendations to them, provide some guides, increase the self-awareness, and facilitate the self-regulation. Coming to the advantages, assessing the quality of teaching, managing the educational institutions, forecasting the risky students, student engagement, optimizing the resources. Coming to the challenges like ethical and privacy issues, data collection and analysis, data evaluation, integration with the existing system could be the most challenging thing. Because the environment and we developed the environment could be the different, so that could take a longer time. uh, Cost and resource constraints are the very important thing. Top 10 learning analytics systems that are working, we have identified, or like SAP Litmus, Voclap, or Adobe Captivate, Rhyme, which is also called as like Adobe Learning Manager, Clever, Loop, Newton, Lecturo Online, Bright Bytes, ET Analytics, EAB Analytics. EAB Analytics is being used in Bradley University. So this is a screenshot of a Bradley EAB analytics system. You could just go to your Canvas account and then click on navigate option, provide your credentials, and it will redirect to this EAB system site. And here you could schedule your appointments with the professors, and you could collaborate with other students and work on the assignments thing. And here you could see your reports, your calendar, schedules, your grades, your attendance. Like it's very useful tool. And so the list of 15 common class objects and identified using those 10 systems are below listed. Instructors, learners, security analytics, content developers, admins, planners, QA engineers, technical support team, databases, assignments, courses, data exchange protocols, softwares, grading system, chatbots. Proposed class objects are like recommender systems, creative insight engine, intelligent content generators, feedback analysts, and endorsement representatives. So this is the comparison table using the 10 systems, like, and this is the frequency of those used systems we could see here, and the common functions and proposed functions. So the proposed functions are create virtual labs, view streak, attend skill challenge workshop, prompt knowledge stops, get adaptive assessment. View streak is nothing but it tracks your progress, like using the tool, like kind of like your daily login thing. Prompt knowledge stops is like whenever you uh, start reading something, it would prompt you with two or three easy to note points so that you could it could be easy for you. Adaptive assessment is like based on the student intelligence, like it could give you the mode of the assignments, like small, medium, easy. And common functions are like registering the course, dashboard, leaderboard, view the progress of the learner, notifications, create discussions, create assignments. And this is the comparison table. And the prescriptive model we used is agile methodology. So, according to the Standish Group chaos report, it is associated with the highest success rates for all size projects, like small, large, medium. So, the choice between the agile and other traditional methods is very crucial. Once the path is chosen, like it's challenging to switch the methodologies within the project. So, as agile has a higher success rate, we chose it, and it's an iterative uh, approach, like you could see here. We would plan, design, build, test, review. There are different sprints in a project. So, and once after completing the first sprint, then check with the stakeholders if there were any changes, then analyze them and make the changes and include them in an next release. So this would make the life easier for the complex projects. um, Thank you so much, and my teammate Sami will be continuing from here.
Thank you, Hema, for that introduction. Hello, Dr. Roscoff and my classmates. My name is Samir Khan, and I'm going to be taking you guys through to the next part of this presentation. First, we have use case diagram. Use case diagram indicates how user uses the system. On the left hand side, you can see human actors such as instructors, students, system admins. On the right hand side, you can see non-human actors such as databases, data exchange protocols, softwares, chatbots. Here is a graphic user interface of UMLIT, the software used for this case diagrams. We have activity diagram. Activity diagram indicates how exactly the interaction of user with the system takes place. In this case, for example, if a student is trying to access the software system, they first navigate to register, select register course, select course instructor, add course, select payment method, and then try to redirect towards the home. This is the graphic user interface of Microsoft Visio that has been used to create this activity diagram. Swim lane diagram. Swim lane diagram helps software engineers to direct the flow of user based on the activity diagram. Here you can see the four actors, namely students, databases, and courses grading system, and the interaction of the actors based on the activity of a student. Right from starting logging details, checking on the databases for the existing details, or when adding the course, checking the course details and checking the grading systems as well for the grades. This is the graphic user interface of, again, Microsoft Visio, the software that has been used to create the swim lane diagram. We have next class or data object diagram. We have class object diagram here indicating the different actors, human and non-human, with various attributes and methods that are available to them. The top two rows indicates the existing 15 common class objects that we identified in various software systems, and the bottom 5 tabs indicate the new proposed class objects. This is the graphic user interface of IBM Rational, the software system we use to create this diagram. Next we have entity relationship diagram. Entity relationship diagram indicates how different entities have various relationship with them. How do they interact with each other? For example, here at the students table, student ID is a primary key to this table, whereas instructor ID is a foreign key from the instructor table. We have many types of relationship here, one-to-one, one-to-many, and many-to-many as well. This is the graphic user interface of SmartDraw, the system we use to create this entity relationship diagram. Next is context data flow. Context data flow tells us the interaction of various actors with the central processing unit. In this case, the unit is called to Access Digital Learning Platform. You can see various human, non-human actors along with proposed actors as well. These legends indicate the number of functions that instructor or other actors can access. For example, assignments can have 1 to 17 function number, and if we go to the next page we can see the various functions that we have. This is the graphic user interface. The system used here is SmartDraw. Level 0 data flow diagram. Level 0 data flow diagram is a little bit more detailed than context data flow, which covers the top overall part, overall governing function of the system. Here we go deep down and indicate the different actors, the functions, as well as sub-functions, temporary databases and permanent databases. And it shows the flow of information between different units. These are the different methods that are available to different actors here. And this is the graphic user interface. Microsoft Visio is here used for creating this diagram. Next, I hand over to Saryu to take you guys through to the next part of the presentation. Thank you so much.
Thank you, Samir. Hello, Professor. Hello, everyone. I'm Saryu Reddy. Next, we are going to see the state transition diagram. The state transition diagram shows the various states of the learning analytics and the transitions between the states caused by the different functions. As you can see, the new user needs to sign up to access the website, and if the person is already a user, he just needs to log in with the valid credentials. If he does not use the valid credentials, there will be a temporary logout to access the website. After accessing to the website, there are the different functions like view, dashboard, register course, get help, access grades, etc. For the one of the function, as we can see, we can view dashboard, in which we can select course, view feedback and continue the progress, and next after that it will be redirect to the home, and from where we can log out. The GUI used for the state transition diagram is the Microsoft Visio. Next is the data flow architectural diagram. In the data flow architectural diagram, make sure to organize the data movement, which makes possible to a clear understanding of an information processing in the learning analytics system. We can see as this is the data flow architecture model of our system, and the GUI used for the system is a Microsoft Visio. Next is the hierarchical design model. In the hierarchical design model represents the hierarchical decomposition of the complex systems. It helps in architecture and the functionality of the different levels in a more systematic way. I know, as you can see, it has a 5 subsystems. It has different components. The 5 subsystems of the learning analytics are graphic user interface, application logic, data database management, integration, and the security. Each subsystem also has the different like points, as you can see. The GUI used for the hierarchical design is the Microsoft Visio. Next is the user experience components and attributes of the hierarchical model. In this model, there are 7 components. Like as you can see, there are 7 components like text box, checkboxes, buttons, hyperlinks, drop downs, random buttons, and the progress bar. You can see the examples of these. You can see the examples of these components like user ID, password, search filter, and for the text boxes, and for the check boxes we can see remember credentials, remember payment method, required courses, etc. And there are also the attributes for the each components. For the components, like for example, for buttons they can see like type, background color, ID, padding, and etc. The main use of this diagram is they organize the components of a learning analytics system, and traits are organized in the hierarchical framework by the hierarchical model. The GUI used for this is the Microsoft Visio. Next is the user experience functional hierarchical model. This shows the functional aspects of the user experience. It breaks down the user experience into the functional elements of the different levels. As you can see, the different levels like for login, codes, catalog, dashboard, view, discussions, tools, help, and logout. After all the functions, they are directed directly to the home page. As the GUI used for this model is the Smart Draw. And next is the LOC based project estimates. These is used to estimate the project cost and the project effect by using the different system function and the programming language. We estimated the LOC as 1.4 million. Using that, we can estimate the total project cost and the estimated project effort, which is 35% months, and the project cost will be 5.6 million. And next will be the FP based project estimates with the system with the different system functions. The FP point will be 629. As we can see, the total estimate project cost will be 7.39, and the effort will be like 46% per month, or 3.8 years approximately. Next will be the empirical model based estimation. As you can see, for the different mode, there are different constants. These constants are constant parameter for the software project. For basic COCOMO model, using these constants, we have calculated the effort, development time, average staff size, and the productivity of the 3 different modes, which is organic, semi-detached, and embedded. With these, we can effort of the organic mode will be 25% months, and the effort estimated is semi-detached mode is 25.5% months, and the embedded will be 25.5% months. And next will be the hardware recommendations. For the learning analytics systems, we recommended the operating system to be the Windows 10, and the processor to be Intel with 2.6 gigahertz, and the GPU will be like NVIDIA and GeForce GTX 150. And we have like RAM, storage, and cache size, and monitor resolution, internet and web browser that which we recommend. And last would be the conclusion. Like the learning analytics system proposed software is like is doable. Is doable. As the project efforts and costs are high, for improving the accuracy, we need to have the detailed analysis of the project activities, task, risk, expected outcomes, and the coding and texting. Next, the detailed case diagrams must be created with each scenario before proceeding with an implementation. And last, the learning analytics can change how we measure the success in learning, but it still is the really early stages. This method for using it and making sure the results are accurate are improving quickly. Thank you.